Today I want to talk to you about our new TiDL technology, or time domain link technology. So if you take a look at a typical installation, you've got the relay and the control house. And then out in the yard, you've got your circuit breaker and current transformer and voltage transformer. And you need to get all those signals into the relay. And so what we do is we run all those copper conductors. And a typical installation can have many, many conductors, some as many as 80. With today's new technology, if we can digitize those and send them in over fiber, we'd have a much better solution. So the concept here is to take your relay and have it talk over fiber out to the yard with a remote module. And that remote module has all those copper cables, a very short run, and then you go fiber. That's the concept, okay? Pretty cool. About 15 years ago, the IEC committee started working on how do we standardize this so that you can have multiple vendors work on this. So the IEC committee came up with what's called the IEC 61850-9-2 sampled values. And here's what they ended up with is a relay compatible with that protocol, and then the remote module in the yard, they called it a merging unit. Okay, now we need to get the signals from the yard and then over fiber to the control house. They wanted to be able to share the data from one merging unit with multiple relays. So what they came up with was, well, let's use a switched Ethernet network. Challenge with that is the signals don't always get from the yard to the relay in the short time, and we don't know when they're coming in, so now we have to add a clock to time tag everything. So there's where we started, there's where we wanted to go, and the IEC committee came up with the 9-2 standard. However, there's challenges with this. There's an Ethernet network that's now out in my yard, and it can extend your electronic security perimeter beyond the control house out into the yard, so it becomes a security problem. The other challenge is now I've gone from 1 or maybe 2 electronic devices to maybe as many as 7 to do your protection. And if any one of those fails, you no longer have any protection. So now I've got a reliability problem. And then finally, I've got to get signals from the merging unit back to my relay. I've got to digitize them, move them through a network here, and then digest them over here. And I take a speed hit. So the other problem is it's a speed problem. So those are challenges, and we worked with customers, and they said, hey, SCL, can you come up with a solution that's more point-to-point? Yep, we can do that. We took our existing 400 series relays and our Axion module that communicates over industry standard EtherCAT communications and created a solution that looks just like that. And that's what we refer to as our time domain link or TiDL technology, which is really cool. So it addresses the problem with the security. It's a point-to-point. Reliability, there's only 2 devices instead of multiple, and the speed's pretty darn good. And let me explain that. So if you look at our 400 series relays, they're sampling the power system at 8,000 samples per second, and they'll trip a circuit breaker in about 8 milliseconds. The 9-2 standard calls out a sampling rate of 4,800 hertz, so it's almost half of the 400 series, so it's going to be slow there and miss some signals. And the standard is silent on tripping speeds. They don't call it out. Meanwhile, our competitors, they're speccing 24 millisecond trip time. Our TiDL solution samples at 24,000 samples per second, or 24 kilohertz, and it trips in 400 speeds plus a couple milliseconds, so it's somewhere around 10 milliseconds, so not too bad. So why is this important? Well, our time domain processing that we're releasing in the T400L, we're sampling at 1 million samples per second, and we're tripping in 1 to 4 milliseconds. And our TiDL technology now samples at 24 kilohertz, but it's going to go to a megahertz. That's the future. That's where we're going, and that's why the TiDL solution has a much better future than the 9-2 standard.